that we master this topic so that when it comes, at least you are exposed to all the types of questions and you are ready for any type of a question. Let's see. So I did send you guys an inbox with this question paper. So again, in today's lesson, we are going to have that interaction that we had in our maths class. So question number 3, you are advised to start on a new page. A ball is dropped from the top of a building which is 20 meters high. So they tell you to ignore the effects of air resistance. Okay, 3.1, now they want you to define the term free fall. Anyone who wants to give it a try, just unmute, mention your name, and I will choose. By now, you should all be knowing how to define that term. Anyone who wants to give it a try. Guys, anyone to define the term free fall?
Yes, sir.
Is it Nomfundo? Who's speaking? Is it Lufuno or Nomfundo?
Yes, sir.
Yes, go for it, honorable member. Define the term.
It says the motion of an object when it's falling under the motion of an object when it's falling under the influence of force of gravity only.
Are you reading there?
No.
No. I don't trust you, honorable member. When we are, how do I say it? We are funda lapho ne. We are funda lento le. I know. But just make sure that you go in an exam knowing that definition, because you will definitely be expected to just state it without using or referring anywhere, either in your notes or wherever. Yes. Okay, then it's fine. So now, moving on to the next question, which says 3.2, calculate the following, being 3.2.1, speed at which the ball hits the ground. So I will definitely need someone, especially one who has worked it out, to guide us in terms of how you approach this question. What are the things to consider? How you choose the formula, how you substitute the sign up and down, how you represent your answer. So maybe let me say, fortunately, I won't write it so that I give you guys an opportunity to get it wrong, so that you will know exactly what you do in an exam. Anyone wants to give it a try, honorable members? I'm sure you've done it already. It doesn't matter whether you are sure or not. Who's speaking? Atayanda, is it you? Anyone wants to give it a try? Guys, anyone who wants to give it a try, or do you need to work on it in case if you haven't worked on it?
So can I try?
Who's speaking now? Is it
Mandlonke,
Mendlonke?
sir. Yes, sir.
Okay. Mendlonke, go for it, honorable member.
Okay, so first things first, we need to consider what we have first, like our data.
Mm-hmm.
So far, what I did, first things first, our V final. Sorry, our V final, we don't know what it is. That's what we're looking for.
Mm.
Our initial velocity is 0 meters per second.
Okay, but how do you know? Because they did not give it to us.
Initially said it was at look at the statement carefully. A balls dropped from the top of the building at 20 meters high. Ignore the
Mhm.
effect of air resistance. Well,
Ye-
technically they didn't tell us that. I was under the assumption that the object was at rest initially. Initially it was at rest.
Yes, 100%. So you simply say when it is being dropped, it means its initial velocity is 0. So that's how you know. Okay, continue.
We know our A is constant. It's 9.8 meters per squared. The acceleration due to gravity, it's 9.8 meters per squared.
Yes, so I don't know why Mendlonge, maybe i- everyone must just confirm with their teachers.
Okay.
One is not constant. Which constant is G, which is for the vertical. Again, you can still have A in the vertical, especially, let's see, can you even have it in is that for when we talk about free fall, we talk about G and not necessarily A. I'm going to share my screen. I'm aware that it disappeared. Thing is now, when the battery is low, it just keeps on, it's like it's on safe power mode. So I just have to every time. Let's see. I hope now you can say, okay, Mendlonke, continue.
So, sir, we know our displacement. We're already aware of our displacement. It's 20 meters.
Okay. So how
So
much
now that
of
we
it,
got all our data, now,
Mendlonke?
sir,
How much of information do we know or do we have?
let's see. We got the V final. We're looking for the V final. We're given V initial. We have our G and we have displacement, meaning the only formula that I could consider would be V final equals to V final squared equals to V initial squared plus 2 multiplied by G multiplied by acceleration due to gravity multiplied by displacement.
Okay, I would agree with you on that one, honorable member, based on the information that we have. Maybe let me quickly go there to say when we look at those formulas, that first one we can't because we don't have time. That means any other formula that has time we can't use. So we are forced to use that one because it's the only one that does not have time. Okay, then it's fine and long game. Now let's talk the issue of the sign. How do you choose the sign?
Sir, I can hear you. Sir, you're lagging on my side. I can't hear you.
Mendlonke, are you still there?
Yeah, sorry, I couldn't hear you for some reason.
Maybe
And you're
I
still
was
lagging, sir.
disconnected, but it's fine. Let's see. So I was saying, what about the issue? Yeah, that means it's the network on my side. How about now, Mendlonke? Am I still breaking?
So far it's good. So far so good.
So let's try. So see, what about the issue of the signs? How are you going to decide on the signs?
Well, we already know. We already know about V. We already know about our V initial. We just have to substitute the value. We just have to substitute the values we were given before. Sorry.
Okay, what is the sign
So-
for V initial?
Sir?
The sign for V initial. So I'm just trying to get us to talk more about deciding on the directions. Whether up being positive, down being negative, before we substitute. How do we go about that one?
Before substitution. Oh yeah, the direction in which one of them is the direction in which one of them is positive and one of them is negative. Correct, sir.
Okay, maybe you tell me which one will be positive, which one will be negative.
The problem is I don't really do the direction. I just went straight to the formula because we were only calculating V final, so I went straight to the formula.
Okay. So in this instance, you will then need to just say, at least let us know. For example, you say take up as positive, take down as negative, or take down as positive, take up as negative before you substitute, so that we've got an idea of the selection of the choice in terms of the direction. But it's fine. What did you substitute? Or how did you substitute?
I sub V squared equals to 0 squared, which will just be 0 at the end. Plus 2 multiplied by 9.8 multiplied by displacement, which was 20 meters.
So according to that substitution, it means you assumed down to be
Positive.
yes, positive. So if your down was negative, obviously 0, whether it's negative or positive, it makes no difference. 2 is a number. What was going to be the sign for your G?
Our G would have been negative 9.8.
What about for the displacement?
Sir?
What about for the displacement? What about its sign?
Sir, I can't hear you.
Okay. Let me check something. So I was asking Mendlonge to see what about the sign for the displacement, or I was saying, how are you going to substitute the displacement? Can you hear me now?
Yeah, I can hear you, sir.
Yeah, so I was saying, what about the displacement? How are you going to substitute?
We initially said that if our downward was positive, then our displacement would remain as positive. And if we said that our downward was negative, if our sorry, our displacement would be our displacement would be negative since it's dropped from the top of a building 20 meters high. God, I'm sick.
Okay, then it's fine. Just wanted to verify if you understand that part. So you are correct in saying as it goes down, if you assumed down to be negative, the displacement will also have to be negative. Someone will need to remember that displacement, it is a vector quantity, which means it has both the magnitude and the direction. So the reason why it becomes negative is because the ball is covering distance in the downward direction. Okay, then what is the answer there, Mendlonge, as you calculate it?
If down was still positive, my final either way, my final answer was 19.7.80.
19.80. Yes, that is the correct answer, honorable member. So what we just discussed, Mendlonge, is exactly how I would like others to also engage. But wait, is it everyone getting that answer? Or anyone who has got a different answer, so that we can clarify where the problem could be? It has to be Yes, anyone who got a different answer?
Sir,
Yes.
sir, I got the same answer, but so I chose up as to be positive, right? So obviously my my acceleration is going to be negative. But why did you like? I don't understand why you said displacement will also be negative. Like, may you please explain that again?
So the first part is to understand that displacement is a vector quantity. Do you get as Ray?
Yes, sir.
So this ball, as it goes down, is covering the downward displacement. That is why the displacement is negative. So it's more like that negative, it simply tells us that the object, as it covers that distance, is on its way up, but on its way down. So if you substitute it as positive, it means that particular object is covering that displacement on its way up. I'm not sure if it makes sense. An easy one to understand, but you just need to understand that object as it is falling, is it covering its displacement down or up, Serene?
Are you asking if the distance is covering up or down, sir?
Yes, so I just want to confirm, they say that object, is it covering the distance on its way up or down?
Down.
And what did you assume down? You assume your down to be positive or negative?
Negative.
That's why the displacement is negative. It's because the object is covering the down displacement.
Oh, so basically it shows the direction in which the ball is moving.
Yes, it's like it is telling us whether the object is
Okay.
going up or down.
Okay. Okay.
So it's like it is telling us the direction in which the displacement is being covered. So the displacement is being covered in the downward direction. That's why displacement is negative.
Okay. Thank you, sir.
Sense, Serene? I'm not sure if Serene is able to hear me, but I think the honorable member understood what we were talking about there. But now Okay, guys, I did notice that I was disconnected. Sengbuile Manj. Let me quickly share my screen. And let's see. Okay. Serene, before we continue, I think my last question was just to verify if you understood. And I had to assume that you do. But let's now move on to the next question, being 3.2.2. Anyone who has done it, anyone who would like to take us through regarding how you work it out?
Sir, I think I can potentially help. I haven't done your work yet, sir, because of like heavy tests that are coming up this week. But like I think I can try and do it right now.
Okay, then it's fine. Go for it, the Ma'ali. So 3.2, they want you to calculate the time taken. Yes, just make sure that you touch on everything, just like I did with a Mendelonke there, just so that one has an idea of what to consider, what to think about it, what to think about in all of that.
Well, sir, I'm just seeing this. So we've got V initial, which is 0 meters per second down. I'm gonna assume down is negative because down is positive because that's easier for me.
Okay.
So V initial is 0 meters per second because that's when it's dropped. V final would be 19.8 meters per second because that's the speed it hits the ground. Acceleration will then be what's a 9.8 meters per second. And then we're trying to calculate delta y. So the easiest equation I would think is delta y is equal to, in brackets, vi plus vf over 2 all multiplied by delta t.
But wait,
Oh, we don't have time.
Oh,
I just realized that we don't have time. So we can use the second equation, which is vf squared is equal to vi plus 2a delta y.
Vx squared plus, okay.
Vi
So
squared.
what are we calculating there, the Ma'alis?
So we're trying to figure out, we're trying to figure out time. Yo, so sorry, I'm like, I'm sorry. Yeah, we're trying to figure out time. So we would use the first one and then we just solve for time.
Okay, then what will the time be?
So I'm just busy solving it right now. 20,
Okay, then fine. You can quickly work it out.
Okay. So sir, I get time is equal to 2.02 seconds.
2.2 2.0 seconds.
2.02.
2.02. Okay, then it's fine. Let me quickly check if other comrades agree with you on that one. Guys, do you all agree with that answer? Or there anyone who got it? Yes, Rain.
So I got a different answer.
Okay, what did you get?
I got 0.49, 0.50 seconds.
Okay, how did you calculate it?
Okay, so I use that same formula as Ali used. So which is delta y v is equal to v over v initial velocity plus final divided by 2 times change in time, right? But for my final the value for my final velocity, I used the 9.80 meters per second as my final velocity.
Wait, why 9,80?
19.
Okay, you used 19
No,
as your
19. 19.
19, yes. So
19,80.
what was your initial?
0.
And then, okay, what about delta y?
Delta Y, it was 20 meters.
And then what did you do to solve it?
So I took changing Y to the other side, and then I divided so what I got from when I said 19,80 divided by 2, I got 9,8, 9,9. I divided 9,9 by 20, which will give me 0,50. Oh, I realized my mistake. It's fine, sir. I realized my mistake.
Wait. So impossible. And you know what happens when you call tantrum?
Yes. Big trouble.
I was just going to tell them not to take you to the bars, but to take you to primary honorable member. Serene. Okay, it's fine.
Yeah,
So that answer should
I
be
just
correct.
realized my mistake now.
Yes, so it should be
Thank you, sir.
0.02 seconds. Okay, before we move on, anyone who's got a question or getting a different answer on that one before we move on to the next question? Or are we all okay on that one, members of parliament?
I'm good, sir.
I'm fine on my side.
Rufin, a blessing, okay, then it's fine. So very quickly, let's look at that 3.3, which says state a velocity time graph for the motion of the ball, and they say no values required. Anyone who can describe or explain how that will look like? Just think about it.
Sir, I have
Speaking now.
said to
Okay, yes, honorable member, go for it.
sir, I have it sort of looks like a right angled triangle.
Something like that.
A right, like, sir, I get it, it's the y axis and the x axis, and then
Yeah.
a line going,
No,
and
you
then a
can
line
just angle. Because if you say 1 degrees, I will do something like that as 1 degrees. Something closer to 0. Which direction or at what angle should I draw?
it's a I
Or
don't know what
something
to
like
say. No,
Hmm?
so like the line starts from the y axis going to the x axis instead of like a
Oh, but
diagonal
straight
line. Yes,
like that.
yes, and then velocity is the y axis and time is the x axis.
Okay, velocity in meters per second, and then time. Okay, there is an attempt. So my question to you guys is, do you agree or have you got something different, honorable members? Do you guys agree or have you got something different?
Well, sir,
Okay.
for me, It really depended on which side was positive or negative.
Okay, then maybe let's use that same Cartesian plane. We will just use that same one. Where will your line start and where will it go?
Well, so since this is a velocity, what's a time graph? In the beginning, it starts at 0 meters per second, so it would be at the intersection. It would be at the
Okay,
origin of the graph. It would
okay,
start there,
and then
and then as time progresses, velocity would increase. And since down is positive, the graph will go upwards at an angle.
an estimation of the angle.
So, since it's going at like, I don't really know the angle, but it would be definitely less than 90. So I draw about like a 45-degree angle or less.
100, it has to be 45. It has to be a 45. So the D, let's discuss, honorable member. This is how it should be. The reason is, you ask yourself a question to say, if you want to know where your line starts, you ask yourself a question to say, what is the initial velocity of the object? The D, maybe unmute so that we can chat about that one.
Yes, sir.
Yes, sir.
Yes, what is the initial velocity of that object?
So it's 0.
It's 0. So that means your thing is going to start there at 0. When it comes to the direction, this is how you interpret it. You say, as time goes on, what happens to that? Does it increase or does it decrease?
Increasing.
Yes, it increases. So that is why as time goes on, your thing keeps on increasing. Can you see there the D?
Yes, sir.
Yes, and they said without or with no values required, you just leave it as it is. But it just shows that, okay, as time goes on, the velocity increases. And this graph, that's if we assume down to be positive. So that means we
So
had to ask.
So I don't think I understand.
Who's speaking now?
So it's me. It's still.
Who is me? Okay.
So,
Let me explain it again. I'm just wondering if I should add. Let me add that. Okay. There I agree, the D. There I agree. This is our V in meters per seconds. And then this is the time in seconds. Okay. So the question now, the D, is that what is its initial velocity?
it's 0.
It's 0. Okay. Since its initial velocity is 0, it means it is going to start there. Remember, this is assuming that up is positive.
Yes.
Am I losing on that one, Chekhov, assuming up to be positive?
No, sir. I'm still with you.
Okay, let's just make an assumption. From its velocity being 0, after 1 second, what do you think its velocity will be? Just an estimate. From the moment it dropped. So it's more like from the moment it's dropped, its velocity, does it keep on decreasing or increasing?
So it increases.
So if I estimate, can I say maybe in 1 second, its velocity will be, let's say 1 meters per second. And then say after 2 seconds, it just keeps on increasing. Maybe it's somewhere there, being something like 4 or whatever there. Then I can just put those dots to say, okay, after 1 second, it increases. After 2 seconds, it increases. What about after 3 seconds? It just keeps on increasing. So what they wanted you to sketch, it is a velocity time graph. So the graph will be that one. It can just end there because they said, don't show us the time and the speed. So that means that you had an option to have your function looking funny. Either be like that, that from the origin, or maybe having it like that, or maybe having it like that, something of that nature that we. But you see, the moment you have it just like you had it initially there, can I interpret what you had the D? So that means according to you, initially velocity had a certain amount initially. Then as time goes on, it keeps on decreasing until its velocity is 0.
Okay.
That's how we interpret your function.
Okay.
So just remember, honorable members, there's that lesson that I did which explains all the types of graphs. It could be velocity time graph, displacement time graph, all those things. Just make sure to catch it up so that you've got an idea of how to interpret these graphs. But do you now get it, the D?
Yes, I get it.
Okay. Anyone else who's got a question, or are we all okay on that one? Guys, Ata, Blessing, Liemalufuno Lonke Mita, Mfundo Ntati Rufin, are we all okay? Helri, are we all okay there?
Yes, I'm fine, sir.
Yes, sir.
Okay, then it's fine. It's fine. Remember, guys, just in case if you've got a question, just yes.
Sir, I just wanted to confirm if the lessons for the graphs were posted on the channel.
Yes, it was posted on the channel. Otherwise, if you can't find it, you can just drop a WhatsApp inbox and then I'll forward it.
Oh, okay, sir.
Who is speaking now?
Ntati.
Okay. Then it's fine. So now I'm just going to delete that. And then maybe this one, let me delete so that if it happens that we have to do revision whenever, then let's see. Then we don't have those answers there. And I'll also remove that. Okay, then it's fine. So there was another question that I had. Let me quickly check where that question is. Wait, what's happening there? No, wait. Okay, I understand why. There's another question that oh, yes. Let me do this, honorable members. Okay, then it's fine. Someone please remember to mute your mic. Someone who's got their mics unmuted. Where is that question? How? Oh, yes. Yes. This is the question. This is the question where they say a man throws a ball. No, a man throws ball A downwards with a speed of 2 meters per second from the edge of a window, 45 meters above a dam of the water. 1 second later, he throws a second ball B, downwards and observes that both balls strike the surface of the water in the dam at the same time. No air resistance, so no air friction. 3.1, they want you to calculate the following. 3.1.1, speed with which ball A hits the ground. Anyone who wants to give it a try on double members? One has got their mics unmuted. I'm not sure who that is. Okay, see. Guys, anyone who wants to give it a try,
May I please try, sir?
take your time, read the statement. You know, who's speaking?
Ntati.
Yes, Ntati. Let me mute everyone else and then I'll leave you unmuted. Please. Where is Ntati? Okay, there. Okay, Ntati, go for it, honorable member. How are we going to work it out? Ntati, can you unmute yourself, honorable member? Let me do this. Where is Ntati? Molepe. Ntati, can you unmute yourself? Ntati, can you hear me now? It looks like yeah. Okay, for the last time, let's try. Ntati, can you click on unmute on your screen? Let's try again. Tati, can you unmute? Maybe I'm the one who's disconnected, but I don't think so. Guys, anyone would like to give it a try? How am I disconnected? Or what's happening?
I tried it.
Who's speaking now?
It's Tiro.
Okay, Tati send me a WhatsApp inbox. I'm not sure. It's a voice note, then I can't listen to that. And I'll listen to that later. Okay. Let's see. The D, it's fine. Go for it, honorable member. How did you work it out?
So I said take downwards as positive, right? Then I used the formula VF square equal to V initial square plus 2 acceleration change in Y. Then
Okay.
then I substituted 2 meters per second as my V initial squared plus 2 multiplied by 9.8 multiplied by 45, and I got an answer of 29.77 meters per second.
29.77. Okay. 29.77. Guys, are you getting the same answer or anyone who got a different answer?
I got the same answer, sir.
Same answer. Okay. Then it's fine. In case someone got a different answer, you will just let me know. But let's look at the next question, which says time it takes for ball B to hit the surface of the water. I don't want to talk much because otherwise I'm going to give you some hints, but I'll leave it there. My question to you is, anyone who has given it a try or would like to just give it a try and let us know how you would approach that question. Just think about it, honorable members. Just read through that statement again and think about it. It just has to make sense when you try to interpret it. Also, if you've got no idea, just make sure to make me aware that you completely do not have an idea, just so that I don't find myself waiting, whereas you completely don't have an idea. Otherwise, we're going to both wait until Jesus comes back, honorable members. Oh, you guys unable to unmute yourself? Let me check. Because I believe I'm still connected. Guys, are you still working on it? Are you guys working on it?
Yes, sir.
Okay, then it's fine. Let me not rush you. I'll give you a chance to work on it. As soon as you are done, just unmute and say, I'm done. Then we'll discuss it. What's happening there, guys? Are you still working on it? Time it takes for ball B to hit the surface of the water. Ah. Mm. Okay. Rush you. Guys, what's the status? Is it difficult?
So I think I have an idea.
Who's speaking now? Who's speaking now? I'm not sure if you can hear me, but whoever says they've got an idea, okay. I did notice that I was disconnected. So now let's see. Okay, guys, someone said they've got an idea. Even though I'm not sure who that was, but Ali, I saw your comment. Can you explain what you've done?
So sir, what I did was that I calculated the time for ball A since we have the most information for that. So I calculated the amount of time it would take for that to reach the surface of the water. So I used the equation VF is equal to VI plus A times by delta T. And then I solved for delta T where I got 2.83 seconds. And then inside the big paragraph they gave us, they told us that ball B was thrown 1 second before that one, and it reached at the same time. It reached the surface at the same time. So I took 2.83 minus 1. I mean, what was it? Plus 1 to get 3.83 seconds.
So when you added it by 1, let's try to interpret that. Nay. You are correct in saying, okay, let me find out how long did it take for A to travel. Then you say it took it 2.83 seconds. That is correct. But between A and B, which one traveled shorter time? Yes, which one traveled the shortest time? I'm not sure if Ali's still there. Or maybe I'm the one who's disconnected because mic is muted. Okay, let me do that. Okay, Ali, are you now unmuted?
Yes, sir, I just realized that the time would actually be shorter. It should have been -1 because it
Yes,
traveled at a faster speed and still hits the water at the same time. So it actually should be 1.83 seconds instead of 3.8.
yes, yes, that is 100% correct. So, what you do there is to calculate the time it takes for object A to hit the ground. If object A, for example, takes 3 seconds, and then they are saying there's another ball which was thrown down, but that ball was delayed by 1 second. So that means the second ball, if it gets to the surface at the same time with object A, so that means the second ball is traveling faster than that one. So if the ball A took 3 seconds to reach the water level, and then object B was delayed by 1 second, but they hit at the same time. So that means it's going to be 3 minus 1, which is 2 seconds. So that means object A took 3 seconds, but object B took 2 seconds. Sesiqedile manje. Sesiqedile manje. What's left is for you to catch up, honorable members. Sengifuna ubaleka manje. Sengifuna ubaleka manje. Guys, do you allow me to run away?
Yes, sir.
Yes,
I
sir.
think I also need to run away.
Singabaleka manje. Ngicabanga ukuthi let's run away, honorable members. Let's just run away. Sophinda sidibane. Ngazi ukuthi nini, kodwa sophinde sidibane. Let's